All right, general problem number 13. Let's see how this goes. Not as bad as it seems. So 13, right there. A conducting sphere is carrying a negative charge of negative 6 microcoulombs and is placed on an insulating tabletop. A 20-gram oil drop is floating in the air 1.5 meters above the sphere. Okay, so number A just says, draw a free body diagram showing all the forces acting on the drop. The drop is floating in the air. Okay, so there's only two forces acting on it. First, I'm going to do this one. Force gravity, right? It means being pulled down by gravity. And that is equal to its mass times the acceleration of gravity. Here, because it's getting pushed up by that charged, sphere, we have an upward force caused by, well, our equation, K, times Q1, Q2, divided by R squared. All right, and that is number 1. Boom, done. Number 2, or B, is even easier. What is the sign of the net charge of the drop? So it's just asking, what is the sign? So if these things, right, are repelling each other, because this is floating in the air, right? If it was attracting, it wouldn't be floating. This would crash into the other thing. So if this one is negative, the sphere, well, this one has to be negative too, so they repel each other. So B is just negative. That is it. Boom, done. C, a little tougher, says determine the magnitude of the electric charge on the drop. All right, well, how are we going to do that? Well, first things first. Think about our free body diagram. These are equal. Okay, so whatever force gravity is pulling down on it is going to be equal to the force that is pushing up on this drop. So for this one, we can use this equation. Right, force gravity is equal to our mass times acceleration of gravity, and we know in here our oil drop is 0.2 grams. Remember, a kilogram is 1,000 grams. So let me just see. 0.2 grams to kilograms. Yeah, that is 0.002 kg, Kelvin coordinates, times 9.8 meters a second squared. And that should get us 0.00196 newtons, and that is pushing down on the drop. Well, if it's floating there, we know there should be an upwards force of 0.00196 newtons pushing up on the drop with the electrostatic force using this equation. We want to know what the charge of the drop is, right? Yeah, what is the magnitude of the electric charge on the drop? Well, just use this equation. We know K. It's 9 times 10 to the 9th. We know one of our charges is going to be negative 6 microcoulombs, which is going to be the same as negative 6. So, negative sign, 1, 2, 3, 4, 5, 6 coulombs. Don't know the charge on the drop. That's what we're trying to find. And then a radius is 1.5 meters. Okay, so 9 times 10 to the 9th times negative 0.0006 coulombs times, we don't know, so we're trying to find out, Q2, times 1.5 squared. If you do this, so this times this, well, why don't I do that? Okay. So we're going to get 2.25 here. What I'm going to do is I'm going to divide this out. So negative 0.000006 times Q2. All right, and down here what we're going to have, so I'm going to divide this to that. So we're going to get 0.00196 divided by 2.17, I'll do 78 as a round, times 10 to the negative 13th. And that's going to be equal to 0.000006 times 2.25 times 2.25 times 2.25. What you're going to get, and I'm just going to redo everything back over here, 4.9 times 10 to the negative 13th, and that's going to be equal to 0.123456 Q2 divide by 0.123456 divide by 0.123456. So we should end up getting Q2 is equal to what is that, negative? Yeah, negative 8.2 times 10 to the negative 8th coulombs. That's going to be C. All right. Now for this last part, number 5, it's just really thinking, okay? So if these two were equal, up there, so think FG had a, we'll say it, had a -1 down. FE had a a +1. I'm just talking about pushing up, right, pulling down. Well, if this was equal to 9.8 meters a second squared, and this was equal to positive 9.8 meters a second squared, if we doubled this, so times 2, we'll times this by 2, right? And if this is negative 9.8, this is positive, 19.6. If you add a negative to that, overall, your total, right, your new total, so if you did like +2 minus 1, you'd get that +1, which we know is 9.8 meters a second squared. All right, let me know what you think on this.